this example, we assume y to the power 1 by m as a. Therefore, the y to the power 1 by m plus y to the power minus 1 by m equal to 2x. It will be a plus 1 by a equal to 2x. That is equal, or a square minus 2x plus 1 equal to 0. This is a quadratic equation. Or a equal to, using Sridhar Acharya law, we get a equal to x plus minus root over x square minus 1. A means y to the power 1 by m. We assume y to the power 1 by m equal to x plus minus root over x square minus 1. Or y equal to x plus minus root over x square minus 1 whole to the power m. Now we will take only positive sign. Therefore y equal to this one. Taking log from both sides, then log y equal to m log x plus root over x square minus 1. Now differentiating both sides with respect to x, we get derivative of log x, that is derivative of log y. Derivative of log y is 1 by y into dy dx, that is equal to m into derivative of log x plus root over x square minus 1. That is 1 by x plus root over x square minus 1 into derivative of ddx of x plus root over x square minus 1 equal to m by x plus root over x square minus 1 into derivative of x, that is equal to 1 plus derivative of, that is ddx of root over x square minus 1 is 1 by 2 into root over x square minus 1 into 2x. Then 1 by y dy dx, it will be m by root over x square minus 1. Now root over x square minus 1 into dy dx, root over x square minus 1 into dy dx, that is equal to, we can write y into m, that is my. Or squaring both sides, we get x square minus 1 into y1 square. We've already learned that we can write dy dx as y1 also. X square minus 1 into y1 square equal to m square y square. To get second order derivative, that is d2y dx2, we have to differentiate this one again with respect to x. Therefore x square minus 1 into, using as usual u into v rule, x square minus 1 into 2y1 into y2 plus derivative of x square minus 1 to x into y1 square, that is equal to m square into derivative of y square is 2y into y1. y1 means dy dx, or x square minus 1 into y2. Cancelling 2y1 from both sides, we get x square minus 1 into y2 plus xy1 equal to m square y. Here is another example where x and y are in parametric form, and we have to prove this one. Here x equal to function of t and y also function of t. P is a constant term. Therefore x equal to sin t, dx dt equal to cos t, and y equal to cos pt. Therefore dy dt equal to minus p sin t. Now dy dx, as the previous sum, dy dx equal to dy dt into dt dx, or dy dx equal to minus p sin pt into 1 by cos t. Now squaring both sides, we get dy dx whole square equal to p square into sin square pt by cos square t, or y1 square equal to p square into sin square pt by cos square t. Now we will convert all the terms with t into x and y. So here is cos square t and sin square pt, but x is sin t and y is cos pt. To get sin t, we will write cos square t as 1 minus sin square t, and we will write sin square pt as 1 minus cos square pt. Therefore it will be 1 minus x square, since x equal to sin t, 1 minus x square equal to y1 square, that is equal to p square into 1 minus y square. Now to prove this one, we have to differentiate the equation again. Therefore, differentiating both sides with respect to x, we get, this is a product of two functions. Again, using u into v rule, we get 1 minus x square into derivative of y1 square, that is 2y1 into y2, plus y1 square confixed, and derivative of 1 minus x square is minus 2x, that is equal to p square. Derivative of y square is minus 2y into y1. Therefore, taking common to y1, 1 minus x square y2 minus x y1, that is equal to minus 2p square y y1. Now, eliminating 2y1 from both sides, we get 1 minus x square into y2 minus x y1, that is equal to minus p square y, or this one. Therefore, here y equal to e to the power x into sin bx, and proof that y2 minus 2a y1 plus a square plus b square y equal to 0. Now y equal to e to the power x into sin bx, or we can write e to the power minus ax into y equal to sin bx, transferring e to the power x from right side to left side. Now differentiating both sides with respect to x, we get e to the power minus ax into derivative of y, that is dy dx with respect to x, plus y into derivative of e to the power minus ax, that is e to the power minus ax into minus a, that is equal to derivative of sin bx, that is cos bx into b, or taking e to the power minus ax common from the left hand side, we get e to the power minus ax into dy dx minus ay, that is equal to b cos bx. Now to get y2, we have to differentiate this equation again with respect to x. So again differentiating with respect to x, we get e to the power minus ax, e to the power minus x fixed, derivative of dy dx minus ay with respect to x is d2y dx2 minus a into dy dx plus dy dx minus ay constant, that means fixed, into derivative of e to the power minus x, that is minus a into e to the power minus x, that is equal to derivative of cos bx equal to minus sin bx into b, that means minus b square sin bx, or again taking common e to the power minus x from left hand side, we get e to the power minus x into d2y dx2 minus a dy dx minus a dy dx plus a square y equal to minus b square sin bx. Now we can write in this way, that is this term expression, that within bracket, the term within bracket, the expression within bracket, that is this one, equal to minus b square sin bx, and now we again transferring e to the power minus x from left hand side to right hand side, we can write minus b square into the power minus x into sin bx. Now since d2y dx2 is also written as y2, so we can write d2y dx2 is y2 minus 2a dy dx as y1, that is minus 2a y1 plus a square b square y equal to 0. I forgot to tell that e to the power ax sin bx, we put y in place of e to the power x sin bx, since y equal to e to the power x into sin bx, therefore minus b square y. This is the last example, and as the previous example, here we have to prove something. Y equal to, the function is y equal to sine 4 cos inverse x. Now differentiating both sides with respect to x, we get dy dx, that is y1, equal to Derivative of sin x is cos x. Therefore, derivative of sin 4 cos inverse x is cos 4 cos inverse x into derivative of 4 cos inverse x, that is minus 4 by root over 1 minus x square. Now we can write y1 into root over 1 minus x square, that is equal to minus 4 into cos 4 cos inverse x. Now squaring both sides, we get y1 square into 1 minus x square equal to 16 cos square 4 cos inverse x. Now to get y, we will convert cos square x into sin square x, because here y equal to sin 4 cos inverse x and here is cos square 4 cos inverse x. So we can write cos square theta equal to 1 minus sin square theta. Therefore, this will be 16 into 1 minus sin square 4 cos inverse x. Or we can write y1 square into 1 minus x square equal to 16 into 1 minus y square, since y equal to sin 4 cos inverse x. Now differentiating again with respect to x, we get 2y1 by 2, derivative of y1 square into 1 minus x square plus y1 square into derivative of 1 minus x square, that is minus 2x, equal to 16 into derivative of 1 minus y square equal to minus 2y y1. Now cancelling 2y1 from both sides, we get 1 minus x square into y2 minus xy1 equal to 16y, or 1 minus x square y2 minus xy1 plus 16y equal to 0. This much.